Hello everyone, good morning. Welcome to our YouTube channel. On behalf of Physics Made Easy Kota, I am welcoming you all in our next lecture that is on the chapter Electric Field. Electric field. The word electric is related to electric charges, electricity, whereas the field means a region or a space. So what about the electric field in a combination? So electric field is the region or space around a charged body within which its influence can be felt. Or we can say that electric field exists in a region if an electric force is exerted on a charged body placed in that region. Now let us consider a charged body. Suppose we having a body that is having a charge small q, and this one is the field up to which its influence can be experienced. Suppose there is another charge. Suppose that charge will be taken as the capital T, and this charge is coming closer to the area or the field of the charge small q. When the charge T is coming closer to the charge Q, then the charge T experiencing a force due to the electric field of the charge Q. And when we take this charge T far away from the charge Q, then the effect or the influence of the electric field keep on decreasing. So we can say that practically the magnitude of electric force decreases quickly with increase in distance from a charge or a charged body that is producing the electric field, and it may become undetectable after some distance, but theoretically the electric field of the charged body can be considered to extend up to infinity. To solve to about the mathematical relations, we consider theoretically that for the any charge object its electric field extend up to infinity. All humans are not of the same nature. They all have their different identities. Similarly, we can compare such kind of the nature with the electric field. That electric field is also of the different type. First one is a uniform electric field, an electric field which has same strength and direction at every point in the region. Whereas there is another one non-uniform electric field which has different strength and directions at different points in a region. So when we talk about the electric field, its different types, we have to consider the charges. Each charge plays different role in studying the nature of the electric field. So there is a one kind of the charge that is known as a source charge. It is that point charge which is producing the electric field. Another charge that we take into consideration is the test charge, the small charge experiencing an electrostatic force in the electric field of a source charge, and the test charge act as a detector of the electric field created by a source charge. Now we are going to talk about the intensity of the electric field. Intensity of the electric field is due to the source charge at any point in an electric field is defined as a force experienced by a unit positive charge placed at that point. So for this we consider a test charge small q be placed at the point P in the electric field of a source charge that is capital Q. Let force is denoted by capital F, and this force is experienced by the test charge in the electric field of the source charge. Then according to the definition of the electric field intensity, we can say that E, that is electric field intensity, is equal to force per unit test charge. So now it is a time for the short revision what you had learned in the previous slides. So the first question is write formula for electric field intensity. The next one, what do you mean by the test charge and what is a source charge? We all learned about the electric field intensity. We have seen its expression. Now we just recall our knowledge that electric field intensity is a force experienced by a unit positive charge placed at any point in the electric field created by the source charge. So now there is a change in the expression. Here Q naught represent the test charge. In the previous lecture we take the test charge as a Q. Now I am showing the test charge by taking it as a Q naught. There is no condition or no mandatory rule to take the test charge as a Q. We can just specify which one is we are going to take as the test charge. But here is a one more change that we introduce the word limit. Test charge approaches to 0. Why it is needed? When the Q naught approaches to 0, it means that Q naught or the test charge is very small. Why we have to take it very small? So that the presence of this test charge may not disturb the charge distribution of the source charge producing the electric field. That's why we take the test charge as very small, so there is no problem to the charge distribution of the source charge, because source charge have a lead role, that is producing the electric field. We all know that force is a vector quantity, so the electric field intensity is also the vector quantity. The direction of electric field intensity is the direction in which a unit positive charge would move in the electric field if it is free to do so. So now what about the dimensions? So for the dimensions, we just write the mathematical formula of the electric field intensity, then replace the Q by taking it as IT. We all know the formula of the current is equal to charge per unit time, and just rearrange the terms, we get the formula for the charge, that is equal to IT. Then write the dimensions of the force and also write the dimensions of the current and the time. Then after solving it, we get the dimensions of the electric field intensity. So dear friends, it is a time to recall your knowledge. The first question is electric field intensity a vector or a scalar quantity? Here is another question. What is the force acting on a charge Q placed in an electric field? I hope you know the answer of every question that was asked in the previous slides. Now it's a time to understand the physical significance of electric field. Electric field is a property of system of charges because it deals with the charges and it is independent of the amount of the test charge. And electric field intensity of a system of charges can be worked out very easily at any point in the space. Another point that is very important, that it may be same at every point or different at different points depending upon the regions and placement of charges. I hope all the things of the electric field or the electric field intensity are clear to all of you. So keep away negative people from your electric field so that you do not need to apply attractive or repulsive forces on them. So thank you for watching this video. Visit our channel again for the more videos on the physics.